Okay, so here's our last video on equations of functions. So if I give you a function that looks like this, you guys are so amazing at finding everything that I could possibly ask you about this. You could find the vertex, or technically this point, because it's a cubic, is actually called a point of symmetry or an inflection point. So you could find that point as 4, 5. You could also find the domain and the range, the x-intercept, the y-intercept, tell me where it's increasing, where it's decreasing. If I threw in an inequality, you could tell me where it's less than 0 and greater than 0. You could answer whether or not it's 1 to 1, and if it is 1 to 1, you could tell me, you could find the inverse for it. You could also tell me if it's odd or an even function, or neither. And that is amazing. Furthermore, it doesn't matter. I know you guys, if I change this to x minus 4 squared, if I did, let me take that out of there. If I did the square root of x minus 4, if I did the cube root of x minus 4, or I did the absolute value of x minus 4 and kept everything else the same, you could answer the exact same questions. You guys are so amazing at doing all of that. I'm so impressed. So now I'm going to throw one last twist your way. So let me get rid of some of this. Okay, so if we look at this equation, I also could evaluate this function, right? So if I just made a little table of values, x, y chart, and I put in maybe a 0, a 1, and a 2, you know that we're going to take this x and we're just going to plug it in for this x value, right? And then I can just evaluate all of that, right? So if I plug in x, or if I plug in 0 for x, I'm going to get negative 379. If I plug in 1, I'm going to get negative 157. And if I plug in 2, I'm going to get negative 43. So you're okay with that, right? Because this whole side of the equation, this whole side would then just be numbers. When I plug a number in here for x, I could literally just plug that all in my calculator. Okay? So keeping that in mind, let me get rid of that. So what if I give you some information, and what I now want you to find, so here I'm giving you this equation, and I'm asking you to evaluate it. But what if I gave you the information but not the function or the equation, and I asked you to find it? So let me take this, let me get rid of this, and I'm going to take this guy and I'm going to hide this off to the side. So we don't need to be looking at it for now. So I'm going to give you some clues here. I'm going to tell you, I have to give you information. So I'm going to give you that my critical point, I'm going to call it, even though it's, this is my critical point, or my vertex, whatever you want to call it. And I'm going to give it the number 4, or the point 4, 5. I'm also going to tell you that there's another random point somewhere on the equation at 2, negative 43. And I have to tell you what kind of equation we're talking about. So this is going to be a cubic equation. It could be a square root equation. It could be an absolute value equation. It really doesn't matter. So I have to give you at least this amount of information for you to find the equation. So we know that we could go ahead and plot this thing, right? So 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. So this point would be right here, and then 2, negative 43 would be maybe way down here. And then I already told you that it is a cubic equation, so we know that it's going to go through this way and back up this way, right? So that roughly is what our graph is going to look like. But what we don't know, so that's not enough to get the equation, right? Because I don't know. What I don't know is whether or not this thing drops straight down, or if it goes over a little more gradually, or if it goes way over. I also don't know if it's negative. It could have been negative, right? So the points guide me, but they don't give me my equation completely. So I'm going to use the clues that I'm given, and I'm going to write as much of the equation as I can. So if I write as much of the equation as I can, I know it's a cubic equation, so let's start with that. So if I know it's a cubic equation, first of all, I know it's a function. I was told that it was a cubic function. So I know I have f of x equals something, and I know it's cubic. So I know I'm going to have something in parentheses cubed. Okay, so we're done with this piece of information. We've used that piece of information. That's all I know so far. I also know that my critical point, or my inflection point, is 4, 5. So if I know this is 4, 5, I know this is going to be x minus 4 plus 5, right? Because if you recall, you're going to take the opposite and the same as this, right? So I have 4 and 5. So I have used this point. So we're done with that piece of information. So now what I'm going to do is I'm going to use this other point to negative 43. So and this is the most important point of this video. So because I don't know how steeply this goes down, I don't know if it drops straight down or goes way over, the variable that affects that, and I'm going to right now, I'm just going to give it the letter A. Oh, actually, let me make that a different color. So let me make that blue because I want to highlight that. That's going to be letter A because that's going to be my unknown. That's actually what we're going to end up solving for. So this point, just like, remember when we were graphing equations of lines, we used x1, y1 as a point. Oh, there's the bell. So I'm going to give this point, this is point 1, so I'm going to call this x1 and this y1. Okay, and I'm going to put those into my equations. So where would I put the x1 and the y1? Okay, so remember, this is another way, f of x is another way of saying y. So that's going to be my y1. So if I rewrite this equation, I am going to get negative 43, that's my y1. Now a is what I still don't know, so I'm going to leave that as a. And then my x value is going to be my x1 value. So 2 minus 4 cubed plus 5. So now all I have to do, this is pretty straightforward now, I'm going to solve for a, because notice this entire equation is all numbers with one variable, so we should be able to solve for that variable, right? First thing I'm going to do is subtract 5 from both sides. So negative 48 equals a, and then inside the parentheses this is going to be negative 2 cubed. Well, negative 2 cubed is negative 8 times a. Don't forget those are being multiplied. These are not being subtracted. Maybe if you put it, actually if it's negative you probably should put it in parentheses. And now I can divide both sides by negative 8. And if I divide both sides by negative 8, I get a equals 6. So that's awesome. So now I can go back to this equation right here. This equation right here where I had f of x and the variable x. And now I'm just going to put that 6 in for what? For a. And look what happens. So if I plug 6 in right here, let's go back to this equation that I pulled down a long time ago. So can you see this blue equation right here is f of x plus 6, and then x minus 4 cubed plus 5. F of x equals a, remember we found a to be 6, x minus 4 cubed plus 5. So that means that this equation right here is, in fact, excuse me, the equation of the function that I'm looking for. So it satisfies all of these parameters here, and now I can use that to find any old point on the graph or a function. So if I wanted to plug in x equals 7, I could plug that in and find it. If I want to plug in x equals negative 10, I could plug in negative 10 for x and get a value out. So I hope that helps, and good luck on your homework.